Okay, thanks, Ken. At this point, I'd like all the speakers to come up to the front table. We will start the discussion panel of this portion of this. And I don't know if we have two things, Andrew. Do you have any questions from afar yet? We can get to those. Just okay. And how much time do you think we should take for this? 15. Okay. So any questions from the group here? Probably never get these three people in one place at one time again.
How much time do you think you will be able to save when you protrude these bridges as opposed to what you do now?
Right now, we're about a week a girder. And we'll be talking a day. So it's a big savings.
Any other questions? Yes.
All questions. Go there. You put a curvature in that protrusion? That's good.
Yes, we do. We have, and that's a requirement, especially if you're gonna use a cast in place deck. You have to have the camber built in so that when you put the weight of the concrete on it, reaches the profile of the road. That obviously is one of the big things that we have to, you saw our mold there, that's adjustable. But we're building a bigger steel mold as well that will have a lot more adjustment.
John.
This is a question for Wayne. What keeps you up at night that you think composites could help you get better sleep?
Wow. That's a good question. I think I'll go back to, we have, been on the cutting edge, the bleeding edge, and I've always been pretty comfortable because of that support that we've seen. From humane, from industries like AIT, I think I'll just reinforce, I think that's critically important that, that continue. We at DOT, composites aren't my primary job. I have a big inventory of bridges and a lot of other considerations. I like the fact that I can venture into what I think are building better, more durable structures, but, I certainly, need a lot of assistance to get there. And I think that's critical for, universities, for industry to help us and provide that support so we can have the confidence to kind of take that extra step.
Anthony.
Question. Are you now looking for more partnerships to do more of the decks out in Tennessee, or are you waiting for county engineers to look for that solution?
Really, that was, we chose a team to have that was rural part of the Tennessee. A lot of the rural counties get neglected in the funding model. And also, we didn't want to deal with the DOT red tape. So we wanted to choose a span that doesn't require DOT involvement at this stage. I think once we have enough of those, then obviously DOT will have more confidence and maybe lead to easier adoption. So that's the reason we chose 20 feet span and or less. And the client is very happy. He wants many more of those. I think a lot of people don't realize that a lot of rural areas, bridges are a choke for people to get from point A to point B, especially going to schools. Sometimes they drive very far distances because they don't have the bridge to span small creeks and stuff like that. So this technology is almost, the vision is to have, prefab type situation where you can go in and put that up real quick. That will last. That's lightweight. That can be put up with equipment that most county highway departments will have without a whole lot of lifting. So those are the reasons we see for the adoption. The thing that we have to be careful with is we don't want, there has been tons of demonstrations, right? And I'm tired of demonstrations. It's just go use it. There's enough experience right now. I think that's the real, I don't know what it takes, but we're not there yet. But really the advantage of what we see is everything fiber reinforced polymers. We're talking about, there are clever ways of trying to get rid of the retaining wall concept. The foundation being reinforced with FRP bars, the connection to foundations through FRP columns and the space frame with FRP girders, with FRP deck. We're talking about enormous amounts of weight savings. As we said, we got pultruders that have amazing, experience over the years, so they can provide the quality of the material and the cost that is competitive. So I think it's just going to happen, especially for companies like yourself. But I think one of the DOT staff mentioned about having multi vendors, and this is also the key for automotive OEMs because they don't want to build any car with a single supplier, right? So once we get a lot more people providing materials to this space, I think the adoption will be much more higher.
Wayne, would a bridge rehabilitation project that used the G-beam girders qualify for one of the DOT's everyday counts grants in your opinion?
I guess I don't understand. So you're talking a discretionary grant, a federal discretionary grant for some sort of.
The way they describe it is utilizing proven but underutilized technologies. And there's money available, grant money available. State DOTs, it has to be a state DOT or a local DOT that actually applies for it. It can be done in conjunction with partner companies like AIT. From what I have gathered, it seems like a perfect fit.
Yeah, I know the
I'm not
grants.
looking at through a DOT lens.
Yeah, no, we've been very successful at Maine DOT in getting a lot of the federal discretionary grants, and they each one has a little bit of a twist. A lot of them call for innovations, and I'm not even 100% up to speed on what the latest requirements are, but I certainly would think it would be a prime candidate. A lot of times we're looking for a fairly substantial big money project. I think the project that Ken mentioned in Stillwater in Old Town, just up the road, is probably a prime candidate for a future grant.
Anybody else out there? Dayakar, I have one quick question to you. You mentioned at the end, adhesive bond between the deck and the steel girders. So two-part question, were you relying on that structurally? And number two, any durability assessment of that, any challenges, selecting an adhesive? I know from experience bonding steel FRP is not something we take it lightly.
Exactly, yeah, right. So it is a structural part of it. And so we are actually monitoring how well it's doing. What it turned out, the degree of cross-linking we monitored using something called differential scanning calorimetry. So we extracted some samples from the field, and we've been very careful from an academic point of view, but certainly the concerns would be, if we hand it over to folks who don't understand polymer chemistry related issues, we just need to document this. But having, an embedded sensor, and also we are trying to look at if there's a composite action. And so those are the two reasons why we.
Thanks. Yeah, John. Put it in.
So what's the motivation from the DOT to want to censor all newly constructed bridges? My experience has been, and it started from the T21 installation of all the different FRP stuff, that censoring stuff is the last consideration in applying in an innovative material and stuff like that. And since it was the last consideration, there were no monies in the bucket to go ahead and censor the bridge. So recognizing that there's technologies out there today, is it even feasible or possible that sensing bridges is gonna become a requirement, a norm? Is that gonna be your tool in the toolbox, knowing that you've only got so much manpower?
Yes, speaking for, myself and my impression is, I know there's been a lot, huge advances in, censoring of bridges for kind of health monitoring of bridges. To be honest, we struggle with the resources to maintain and do basic preservation on the bridges we own. So, adding that effort, would be a challenge for us for sure. Would it be beneficial? I think in many cases it would be. But certainly a challenge with the available resources that we have.
Be time for one more question if we've got one. Yeah.
I just wondered if any of these bridges that have installed have experienced any flood flows and how they survived those events. Or if the bridges themselves have changed any type of hydraulic analysis for them.
I think the flood flow aspect of interface with hydraulics and bridges, if there's a major flood event.
I'll repeat against those people.
So is,
I wanted to know if any of these installations have ever experienced flood flows, how they did through that, or if these bridges have required any type of different hydraulic analysis.
Yeah, the arch bridges, definitely, because they're with the places where they're used. Hydraulics is important. And obviously there's hydraulic analysis that sets your openings and velocities and things like that. There was a picture up there that showed the bridge in Lowell, Washington, and that's specifically for fish passage. And also to provide a wildlife corridor as well. So you've got bank considerations. As far as I think the latest bridge that's in Hamden, that will definitely see ice and debris, and it was designed for that. So when we do have a flood condition, we look at that. And certainly, I think, Wayne, most of the bridges are designed for plenty of freeboard, which is an advantage to composites because we can adjust the depth of the structure and still maintain a reasonable roadway profile. A lot of the projects that we look at, they don't want to, DOTs want to avoid extensive approach work to the bridges, so they want to keep the road profile pretty much where it is, and yet they want to increase the flow capacity of underneath that structure. And in many cases, they have to do some pretty innovative things in order to do that. And so I think composites is a good solution for that in both the arches and the rear. Does that answer the question where you were going? The only other thing, when you get high flows, we always get the question about what happens when a log comes down the stream and hits the side of a composite bridge. And we've done that analysis to show that it's pretty much bounces